Here we have a SAT math problem. Okay, let's go to the question. In the figure above, line segment PA and line segment PB are tangent to circle O with radius AO equals to 6. If the measure of angle APB is 60 degrees, which of the following is closest to the area of the shaded region? Okay, here using the given information, we have to get the area of the shaded region. Okay, first let's plan how to solve this problem. That is how to get area of the shaded region. Okay, my idea is to get the area of this quadrilateral OAPB, that is the four-sided polygon. Once we get the area of this quadrilateral, then I will get area of this sector OAB over here. Now we have to subtract the area of this sector OAB from the area of the quadrilateral OAPB to get the area of the shaded region. Okay, now let's plan to get the area of this quadrilateral OAPB over here. Here we have two tangents, PA and PB, and both the tangents are drawn to the circle from the same external point P. And here these 2 points A and B are points of tangency. That is, these 2 points, the two tangents touch the circle. At the point of tangency, always the angle between the radius and the tangent line is a right angle. So here we'll have a right angle, and here also we'll have a right angle, because at the point of tangency, the angle between the radius and the tangency is a right angle. Okay, now let me draw a line segment which connects the center of the circle and the external point P. Okay, here when two tangents are drawn from the same external point P, and when we draw a line segment which connects the center of the circle and P, so this line segment OP will divide this quadrilateral into two congruent right triangles. That is, whatever area we have for this right triangle OAP, the same area we'll have for this right triangle OBP. Okay, here once we get the area of this right triangle, one of the right triangles, it can be multiplied by 2 to get the area of this quadrilateral. Okay, and also here we can consider the measure of angle APB, that is 60 degrees. So APB, so this is a measure of angle APB. So its measure is 60 degrees, and this line segment OP will bisect this angle. That is, it will divide this angle into two equal parts. That is, here we'll have 30 degrees and here we'll have 30 degrees. Okay, here let's consider the right triangle OAP over here. Here we have 30 degrees and here we have right angle. And what should be the angle measure over here? It has to be 60 degrees. So that when I add 60, 30, 90, so they will add up to 180 degrees. And the same thing, here we'll have 60 degrees. So that 60, 90, 30 will add up to 180 degrees. Okay, now let's consider the right triangle OAP over here. It is a special right triangle. That is a 30, 60, 90 special right triangle. In a 30, 60, 90 special right triangle, the side which is opposite to the smallest angle measure is considered to be the shortest leg. So in this triangle OAP, OA is the shortest leg because it is opposite to the smallest angle measure. Usually we assume X as the length of the shortest leg in 30, 60, 90 triangle. And to get the length of the next longer leg that is opposite to the next larger angle 60 degree, what we have to do is we have to multiply the shortest leg by square root of 3. That is, we have to multiply this x by square root of 3, then we get x square root of 3. And to get the length of the hypotenuse OP. So hypotenuse means the side of the right triangle which is opposite right angle. To get the length of the hypotenuse, we have to multiply the length of the shortest leg by 2, then we get 2x as the length for this OP. Okay, here already we have the length for this AO, that is the radius of the circle, that is 6. So for x, we have the value that is 6. So we can replace x over here by 6. Then here also we can replace this x by 6, and we get 6 times square root of 3. When I plug in x equals to 6 over here, then this 2x will become 12. Okay, now let's consider the right triangle again, OAP over here. In this right triangle, apart from the hypotenuse OP, when I consider the remaining two legs OA and AP, we can consider one of the legs as the base of the triangle and the other leg as the height of the triangle. We can consider any leg as base and any leg as height apart from the hypotenuse. Okay, here let me consider OA as the base of the triangle, then AP as the height of the triangle. Now we can find the area of this right triangle OAP. Okay, let me write the stuff over here. That is area of right triangle OAP equals to, the formula to get area of a triangle is base times height divided by 2. Here the base of the triangle can be taken as OA, that is 6. We can plug in 6 for base, and we can consider this AP as height. So that is 6 times square root of 3. We can plug in 6 times square root of 3 for h. Let me plug in divided by 2. Here 2 goes into 2 1 times, 2 goes into 6 3 times. 3 times 6 times square root of 3 is equal to 18 square root of 3. Okay, here I got the area of this right triangle OAP. the same area will have for this right triangle as well, because these two right triangles are congruent right triangles. Okay, now to get the area of this quadrilateral OAPB, we have to multiply the area of the right triangle OAP by 2. Okay, let me write the stuff over here. Area of the quadrilateral, let me write it, OAPB equals to 2 times the area of one of the right triangles, that is 18 times square root of 3, that is equal to 2 times 18 is 36 square root of 3. Okay, here I got the area of this quadrilateral OAPB, that is 36 square root of 3. Okay, now our work is to get the area of this sector OAB over here. For that we have the formula. Okay, let me write the stuff over here. Area of sector OAB equals to theta divided by 360 degree times area of the circle, that is pi r square. Okay, here theta is the central angle of the sector. Central angle of the sector is 60 positive 60, that is 120 degrees. We can plug in 120 degrees for theta divided by 360 degrees times pi. R represents the radius of the circle. The radius of the circle is 6, so that is 6 square. Okay, then we get 120. I think we can simplify over here. That is 120 goes into 121 times. Here 120 goes into 363 times. Then we get 1 over 3 times pi times. The value of 6 square is 36. Okay, here 3 goes into 3 1 times. 3 goes into 36 12 times. Okay, so the area of the sector is 1 times pi is 5. Pi times 12 is 12 pi. Okay, here I got the area of the quadrilateral OAPB, and also I got the area of the sector OAB. Okay, now to get the area of the shaded region, okay, let me write the stuff over here. Area of the shaded region. Okay, let me write it over here. Area of the shaded region equals to area of quadrilateral OAPB. Let me write it. Negative area of sector OAB, that is area of quadrilateral OAPB is 36 times square root of 3. Negative the area of sector OAB is 12 pi. Okay, now what we can do is we can use calculator to simplify this stuff. Okay, let me do it. Okay, when I use calculator to simplify this stuff, I am getting 24.6547. It keeps going. Our aim is to get the value which is closest to the area of the shaded region. So in the given answer choices, we have to get the one which is closest to this value, 24.6547. That is in answer choice B, that is 25. The correct answer choice for this question is B.